Hello everyone. I am Jayant Kumar BS. I am from Computer Science and Engineering Department from Avi College of Engineering. We have chosen our topic for the presentation, that is Terraform. So we are going to tell you how to automate the cloud infrastructure provisioning with the help of Terraform. Coming to the point of what is Terraform and why do we use Terraform? So essentially, Terraform is an open source infrastructure as a code tool. So then what do we mean by infrastructure as a code? So we have various infrastructures that can be accessed through the cloud. So some of them can be a database or a network or many features that are provided by cloud providers. So in order, like the way of provisioning the resources using cloud providers like Azure or AWS or Google Cloud is simply through the method of click ops. It's called as click ops. That is, we just go ahead, we click what we want the resources in the cloud provider's website, and then we manually provision it. So in order to automate this process, there is a cloud tool called Terraform, and the code that we write here will be in the HashiCorp configuration language. So coming to why should one use Terraform? In case of large businesses, there is a huge requirement to reduce human errors. So essentially, while we allocate the resources, there might be an error that one might miss some of the configurational options. So if that is the case, then it might sometimes lead to huge losses to the firms. So that's the point of defining a code tool so that you can code and get your resources provisioned and also destroy them when your work is done. Moreover, for the roles of DevOps engineer, Terraform is a must to be known. So let's go ahead and look at the major features of Terraform. The first feature is it provides multi-cloud support. So you can have your network in AWS, you can have your database in Azure, and you can have your compute service in Google Cloud based on your price requirements. So one might be less costlier than the other. So in that case, you can configure your infrastructure in different cloud platforms through the help of Terraform. So as I said, it's also an infrastructure as a code. That's a key feature. And also it supports state management. So in Terraform, through the HCL language, we specify what is the state, what is the desired state that we want to go. And Terraform takes care of taking us from our current state to that desired state. And also coming to the three main things of Terraform, that is plan, apply, and destroy. So we essentially plan what are the resources are required, and then we will be like, we'll apply it. So application basically is we check what are the steps to be taken. That is done by Terraform inherently. After our work is done, we try to destroy the infrastructure. Coming to the workflow of Terraform, so we have five major steps that are done in a normal workflow of a Terraform. The first one is we write a configuration file. So that will be in the HashiCorp configuration language. And after that, we run a command called Terraform init. So Terraform init is a command that recognizes all the providers, all the cloud providers that we have specified that we want the infrastructure from. So, and then it installs all those plugins that are required in order to, allocate the resources. Next, the step 3 comes out to be the plan step. That is, we run the Terraform plan. So what this does is, it enlists all the steps that the Terraform actually is taking to provision the resource. Coming to destroy, I missed the apply one. So in Terraform apply, this is where the actual creation of the resources and provision of the resources happen. So when you hit Terraform apply, it asks for a confirmation of whether these are the steps I'm going to take and this is the output of it. Are you sure of going ahead? We should say yes, and we hit the Terraform apply. That automatically creates the infrastructure within seconds, which will normally take more time when we do it manually. And the last one is destroy. So this is an optional step wherein when our work is done, we can actually destroy the infrastructure that we have created so that we can rebuild it again when we need to work on it in the next time. So this is the basic overflow of it. So moving ahead, if you look at the architecture of this, There are three main things in this. One is the provider, that is the various cloud service providers, that is AWS, Azure, Google Cloud, and many others. Coming to modules, so these modules are nothing but the plugins that these providers are going to provide to Terraform. So these plugins are developed by developers such that they interface the providers and do the necessary job for us, that is the state management. And the next one is state file. So this state file maintains the record or the log of the different states that the Terraform has undertaken. Coming to the benefits of Terraform, it's scalable, and as it's infrastructure as a code, we can bring in version control into it. And also it is consistent, and it helps as we bring in version control, it automatically inherently brings in collaboration too. Coming to the Terraform use cases. So Terraform is used in multi-cloud deployments, or if we want to ensure disaster recovery. For example, if we want to replicate an infrastructure which is provided by one cloud provider into another cloud provider, so that if there is any disaster in the previous one, we can recover from that. Terraform can be very handy and very helpful for that cases. And also it is used in CI/CD pipelines to automate the provisioning and deployment process. So now, as I was telling about the HCL language, so this is a sample configuration. So in Terraform, the files are saved as .tf extension. And coming to, we can see here, we can see two blocks here. One is the provider block, another one is the resource block. So essentially, the Terraform will be made up of blocks. So one of those blocks is a resource block. So this resource is a keyword. And the string that we can see in front of it is going to tell us that AWS, we have written here AWS. So this is nothing but the cloud provider, which provider we are using. If it's Azure, we specify it as Azure. If it is Google Cloud, we specify it accordingly. And if it is a local provider, we can use local keyword. And the part after the underscore tells us what type of resource we are actually going to create or provision ourselves. Here it is an instance. So instance actually means easy to instance in this case. And the next string that is followed here, this string is a user defined name that you give for this entire block of resource. So now within that we have a pair of braces, flower brackets, and in that we can see some key values. This is the key, this is the value. So there are some keys that are optional and there are some that are mandatory. For instance, we can see this is the AMI. So this is the AMI and the instance type. These two are mandatory. There can be many other keys which are given the values and like defined over here, but some are important and some based on our requirement we can provide them. And once we run this file, we can get an instance, EC2 instance getting deployed there and provisioned there. So that is about it. So now let's get into the hands-on and let's try to create a resource. Let's see how the workflow happens and create a local resource, and also actually try to understand how things flow in this, so that we can enhance our knowledge and get ourselves ready for deploying higher infrastructure such as AWS, Azure, and cloud.
So let's begin the hands-on part of the session now. So before going ahead, let's look at the Terraform is an open source tool. So if we look at the GitHub page of it, we see that it's an open source tool and the official website link is there here. So now if I'll begin with the installation for the Windows system, and then I'll try to code the HCL language, and I'll try to teach you the HCL language through the editor called VS Code. So go ahead and you click on install, and then here select 386 under Windows and download the Terraform file. So once it gets downloaded, go ahead and extract this to any particular path that you wish. So I'll extract in this particular folder. I created a folder called Terraform, and here I'm giving it as a path here, and click on extract. So once the contents get extracted here, we need to update this path in our system variables. So go ahead and search for environment variables, edit system environment variables. Under advanced tab, go ahead and click on environment variables. And there are two tabs here. One is user variables, another one is system variables. Go ahead for under system variables, click the path option here and click on edit. Now you have the option of new, wherein I have already added the path here. So what you're supposed to do is click on new and add the path that in which your executable file is present. For instance, it's c/terraform. So I've added that path over here. So once you have added, click on OK and click on OK again and OK again. So now in order to check whether the Terraform has properly installed in your system, go to command line, command prompt, and type terraform/v. So if you get this particular output, that means Terraform has been properly installed in your system. So we have installed the latest version, that is v1.9.3. If you type Terraform, you get the list of commands that we generally use in Terraform tool. So the main ones that I already discussed, they are init, validate, plan, apply, and destroy. And there are a lot of other commands also which we can go through. So now as we have installed Terraform, let's begin to create a resource using Terraform, and let's try coding in it. So head over to VS Code, open a folder. If there is a no folder, create a new folder. Let's name it as Terraform RVC. And let me select this folder. So now I'll create, so all we are supposed to do now is to create a configuration file in HashiCorp configuration language. So create a file called main.tf. So now this is the configuration file in which we'll be working on. So as said earlier, the syntax for like there will be various blocks in a configuration file like this. So one such block is resource block. So the resource block is identified by the keyword resource, and there are two strings that it follows. The first string, we specify the provider and the resource type. So the provider, so now as of now, I'm going to create a local resource. So a local resource is in the sense, I'm going to create a text file using Terraform in an automated manner through this code. So the provider name is local, and after the underscore, whatever we give is the resource type. So as I'm creating a file, I'll give it as file. So now the second argument here, it will be basically the user defined name. So I'll give it as a file. You can give anything you want in this. So now we'll specify the parameters for this resource type. So parameters or attributes. So there are compulsory as well as optional attributes. The two compulsory attributes for this resource type is the file name and content of the file. So let me give the file name as like this, where let me call it as file.txt, and I'll give the content as welcome to cloud computing. So now by this we created a resource now. So in order to run this, head over to terminal and type terraform init. So when you type terraform init, all it will do is it will install all the necessary plugins. For instance, we have a local provider here. So all the necessary plugins that are required for this local provider are getting installed in this procedure. So now it has been successfully initialized. Now, the second step would be to go ahead and type Terraform plan. So what Terraform plan does is it displays what is the steps it's gonna take, or what is the actions that it is gonna take. So here we see the actions. It says local file dot file name. The file name I gave as file will be created, and the plus symbol indicates the creation of resource, and if there is a tilde symbol, it means there is a destruction of the resource. So we see under this there are various arguments or attributes. So we see the file name and the content attributes are given by us. So it is taken as it is. We have the file name here and we have the content here. So the rest all are the default arguments that are provided by Terraform itself. So once you are done with, once you verify this plan, you can go ahead and if it is fine, you can go ahead and type Terraform apply. So when we click on Terraform apply, when we type in Terraform apply, it will show that it is going to perform the following actions. If you're fine with it, type yes. Once you type yes, it's going to create the resource. You see the apply is complete and one resource is added. So we created a file called file.txt and we see the file.txt has been created having the content welcome to cloud computing. So this is a basic way of creating a resource. So essentially, this is the same syntax or pattern to create any type of resource. In place of local, we'll have AWS or Azure. And in place of file, the resource type can be an instance or it can be EC2 instance. So in this way, we can provision the resources as we want. And you see, this happened in a couple of seconds. But generally, if we go through the traditional way, it will take minutes or like hours together if it is a complex infrastructure to be built. So that is one advantage of Terraform. So now we created one particular resource as local file. Let's create one more resource. So this is also yeah, as I said, there are two strings required here. So I'm going to create the second resource that I'm going to create as a random resource. So random is a resource that is provided by the Terraform that can generate random integer, random names, random strings, and random values can be generated. So what I'm going to do, I'm going to take the random local, a random provider, and I'm going to take the resource type as pet. So what this pet resource type is doing is it returns a random pet name for us. So under this, I'll give the name for it as my pet, and I'll just try to mention there are three important attributes that are required here. One is prefix. I can give it as, let's say, Mr. And the another attribute that is required is length. So the length is specified. Length specifies the number of words in which the pet name should be there. For example, if I give one, it will give one word pet name, one worded pet name. So if I specify this, I think that is sufficient. I can even add a separator for this, wherein, essentially, if we give a separator, it acts as a separator between the two words if we are given. For example, now if I give just Mr. and I give a separator as, let's say, dot, then between the Mr. and the generated pet name, it adds the dot there. So let's try to run this. We'll go and click Terraform init. So the Terraform has been initialized. Let's click Terraform. Let's type Terraform plan. So it says my pet will be created. So now let's go ahead and type Terraform apply. Let's give an S. And you see the apply has been complete and the output here is this. We see the Mr. got added. The separator was a dot between these two names, and this is the random pet name that was generated by this provider random pet. So this is how we can define various resources. So this, because each of this is called as a block. So these two are resource blocks, and this is how you can actually use different resources. Generally, like provision yourself with resources, which can be servers or databases or networks in this similar manner. So now I'm going to tell about resource dependencies. So if I want, we have this file.txt with an output as cloud computing, right? Welcome to cloud computing. I want it to be in such a way that I should say welcome, and I want this name, Mr. Jim. If I want that to happen, I'll make these changes. I'll remove this, and we can invoke this pet name over here in this following manner. So you give a dollar sign and flower brackets. Inside that, type random pet dot my pet dot id. So the random pet comes from here, and the my pet comes from here. And within this resource, we are having this attribute id that is being accessed here. So that is the meaning of this. So let's try to see how this works. First, Terraform init, then Terraform plan, and then we have Terraform apply. You see the tilde symbol here denotes the destruction of the resource that's happening. And minus slash plus indicates the resource is getting replaced. So let's type yes, and yeah, I think the it's completed. Let's go to file.txt. You see it has the output as welcome Mr. Jim. So this is how we can invoke one resource values into another one. One important thing to notice here is there are two types of dependencies. One is implicit dependency, and the another one is explicit dependencies. So here, whatever we have done here, this we have specified it in this way, and it is generating the output in this way. So this entire thing is called implicit dependency. So what implicit dependency means is, so which resource should be created first? We see while creating this resource, we wanted this resource, that is my pet resource. So what the Terraform control will do is, it will first make sure that this resource, that is random pet resource, is getting created first, and then the local file resource gets created. That will be the order in which the resource is getting created. We can also externally specify the what do we say, the dependency. So for example, I have it here in this way. I can say with another attribute depends on, and I'll say is equal to random pet dot my pet. Yeah, random pet dot my pet. We add an attribute called depends on, and within that we just specify the name of the resource that we are using here. So it is random pet dot my pet. So this is the name of the resource. So this resource depends on this resource. So that is the meaning. So this is how you can write the two types of dependencies. Sometimes it's essential to like specify the dependencies externally in case of complex infrastructures to be provisioned. So that's about it. So now let's head back to the PPT, and let's see some of the basics again. So there are various data types in HashiCorp configuration language. The first one is a string. It can be a number. It can be a Boolean. There is a Boolean data type. And if no data type is specified, then it will be any data type will be assigned to it as a default value. So using these data types, there can be many other complex data types that can be created. That is, you can create a list, you can create a map, you can create a, let's say an object, and even a tuple too. So coming to the variables in Terraform. So let me practically show the variables for you guys. So essentially, in this resource, we are we are giving the values in a hard coded format. For example, for this file name attribute, so we are actually giving the value in a hard coded format. So in spite of this, if we want to have a single place where we have all the variables that get which we can update at one single place, we can create one more file called variables.tf. So in this variables.tf, you can specify whatever the variable that you want to use. So you use the keyword variable and you use the name for the variable. So it's generally recommended that whatever the attribute name you have, use the same for the variables. And inside the flower braces, you can specify the default value. And here you can give as example.txt if I change the name. So yeah, this is the way in which we can create a variable. So and this variable can be accessed here by typing var dot the variable name that we have given here. It will be file. Yeah. So now what I did is I made this file.txt as sample.txt and let's see if this works. First init. And we did the plan. Now let's click on apply. Let's say yes. And yeah, so the resource got created. You can see we have a resource named sample.txt that got created, which replaced the older resource that was named as file.txt. So that means this worked. So in this way, we can, so for a given variable, default is a compulsory attribute. So there can be other attributes also that are specified. For example, there is one attribute called type, which you can specify. In this case, the type of value that we are sending is string. So we give it as string. And also we can give a description for it. So the name of the file to be uploaded. So you can give a description so that the readability of the code increases. So this is a way, it's not essential that the type and descriptions are required. It increases the readability. So in this way, we can give the variables, that is for all these attributes, we can give the variables in this format itself. So this is one thing that I wanted to say. So going ahead, we talk about the precedence of variables. So let me show another thing here. If I create a variable in this way, but I don't give any, let's say I don't give any value in this, but here it's asking, it's accessing variable.file name itself. So then what happens? Let's see, let's test and try it out. I'll give init and now I'll give plan. So you see, it's asking for the prompt for the value over here through the prompt, right? So it's asking the file name here. I can give it as hello.txt. So whatever I gave here, that is taken there. So it says that the local.file must be like it must be replaced, right? So I gave the name there. Now if I try Terraform apply, yeah, so it asked me the name again. Let me give it as hello.txt. And you will observe that the sample.txt will get replaced by hello.txt. Once I press end, yes, you see that hello.txt has been replaced. So that means if you don't give the definition over here, you can manually enter it in this way. So the other way of giving the variables is you can be like Terraform, and in this plan, you give the variable directly here itself. That is using the minus like dash var command, you can give the variable name directly over here. So the variable name was file name is equal to simple.txt. I think it should be caps. Yeah, it says, okay, let's refer back here. Okay, it should be used in with apply. Yeah. So it says that there is a space over here. So let me remove that space. Yeah. So it asked, did you mean it in this way? So yeah. So I'll give the is equal to also here. Let me type yes. So yeah. So the simple.txt got created and the older hello.txt got replaced or deleted. So another thing about Terraform is it's used to whatever the infrastructure that is provisioned by Terraform, that's actually said to be immutable infrastructure. What do you mean by immutable infrastructure is like once you've created an infrastructure, you can't modify that infrastructure, but instead the particular resource will be created again from first. So like essentially I was changing the file name here, but it didn't change the file name actually in the resource that was already created. It actually created another resource itself. So indeed helps in preventing like outages in case of big firms in the resource allocation or resource provisioning. So that was about it. So that was about how to like different ways of invoking the variables. There are other ways also, such as you can create another file called like .tfvars in which you'll specify all the variables in this particular format. If you don't give in the variables.tf, you can specify the default values over here. So there are these four types of giving the variable names. If you've given all of them, for example, see, I've in this particular thing, it's given as cats.txt. Here it's pets.txt, mypet.txt, and bestpet.txt. When we do all four of this, so which one is Terraform going to consider? So that is about the precedence of the variables that are of Terraform. So the thing here is, it looks for environment variables, and it looks for first it looks for environment variables. So this first format is on environment variables, and then it checks if there are terraform.tf pairs, and then it checks for terraform.auto.tf pairs if you have made any declarations inside or definitions inside this file. And at the last, it even checks if there is a entry of the file name through the command line in the using the /var, I mean -var. So if any of this, we see that the fourth one here has the highest precedence based on the way in which the user has specified, the corresponding name gets updated. So in this case, when all four are done, so the Terraform is actually going to consider this last one. That is, it's going to output in the file with the name bestpet.txt. That was about precedence of variables. Now let's come to output variables. So there are in Terraform, there is something called output variables. So what output variables does is, uh, it actually tells us if, for example, if we are let's say we are provisioning a network, or let's say we are provisioning a database, so there are some attributes or some values that we have to monitor in that case. So we want them to get displayed by putting a command. So that is the main reason why we have output variables. So you can see this is the syntax of an output variable. It will have the keyword output that indicates that it's an output variable definition, and this is the name of the variable that we give, that is defined by the user. So within the flower brackets, we specify the value of this variable. So this value should be given as an expression here. So that is from where should it fetch the value. So that value is actually fetched by from this resource mypet.id. So the whatever the ID is there, that gets invoked here. And once we can give a description also for this, which is an optional attribute for this output variables. And another thing is, we have Terraform output, right? So this command Terraform output, when you run it, this is how the output is gonna be. So whatever the pet name was generated, it outputs in this form. This is the pet name. This pet name is a variable name. and this is the name it was generated. You can give Terraform output and the variable name itself. That will just give the name in this particular fashion. So let's see this in working. Let's type output and let's give a name for it. Let me say pet, and within that I'll give the value, and the value is random.mypet.id, as I said. So we can add an optional description for it, randomly generated pet ID or pet name. Let me say. Okay. Uh, Let me now create the resource. Let me do the initialization of the Terraform, and let me now go ahead and type Terraform plan. You see that it's asking the variable name still because we've just left it this way. Let me say pet.txt. So Terraform plan is also an optional command that lets the user to know what are steps it's gonna take. So the same thing is like provided by Terraform when you click Terraform apply also, and after which only, after reviewing it only, you can like give a confirmation that go ahead and create it. So I clicked on apply, it gave the same suggestions as of Terraform plan. It displayed the plan it's going to take. So now if I click yes, type yes, it says you can see the output here. Pet is equal to whatever the variable name I gave here. Pet is equal to the value of the randomly generated pet name. So you can also type Terraform output to get the output in this particular fashion. You can also type Terraform output pet. That'll just output the pet name. So the specific use case of output variables is when in case if we have something like uh, let's say we have an AWS cluster itself, or let's say we want some of the values from this resource to be passed on to the next software. In this case, it can be an Ansible, which is used like along with Terraform for resource provisioning and resource monitoring in case of cloud platforms. So this was about basics of HashiCorp configuration language, and I also want to tell one more thing that so if we using this we by this we get a proper understanding of how things work in Terraform and what is the syntax of HashiCorp like configuration language. So that will actually help us in going ahead and creating AWS clusters or S3 buckets or many other resources in that format. So yeah, so thank you for that. Thank you for your time, and yeah, thank you. Stay tuned for more things.